All right, let's get started talking about accounts and authentication. This is going to be a vital part of your guys' websites. Okay, so web applications, a lot of them will require accounts, right? You think about Facebook, Google, all these big sites, they have accounts, right? And accounts, in order to have accounts that store personalized data, they will need secure authentication. So today's lecture is going to be pretty theoretical, actually. There's not going to be any hands-on stuff. We're just going to talk about a lot of the concepts behind authentication and how it works, how accounts work. And then at the end, we'll walk through just a little bit of code to see what that might look like in your actual websites. Okay, so by the end of today, we'll have the ability to do stuff like this, have a login functionality, as well as having specific personalized account data show up on the website, such as people's names if they're posting after they're logged in. Okay, so let's start with a question. What is authentication? Right, so authentication is just proving the identity of a person or an entity. So if I had to ask you guys now to give me some examples of authentication, what would you say? Like, what are some things people can use to authenticate themselves? Password, right? So you can use a username and a password to authenticate yourself. What else? What's another way that people can identify themselves? ID, right? So in the US, everyone has a social security number. So your unique social security number, your unique ID is a way to identify yourself. So nowadays, there's a lot more technology that we can use. So your iPhones, right? Now they all have that face scanning technology, which doesn't work when your masks are on. But there's the thumb fingerprint scanner stuff. You have your phone for duo authentication, right? We use that one all the time. So there's a lot of different ways of authenticating yourself. But for websites in particular, the canonical way is to use a username and a password, right? And then once you use that username and password combination, you log into the site. Oftentimes, if you close the site or you refresh, you navigate away and you come back, it'll keep you logged in. So one key feature of authentication is that it needs to persist when you close the site, when you refresh it, when you do all those sorts of things. Having to log in every single time would be pretty annoying, right, for the user. So let's talk a little bit about the concepts behind that and the theory behind how it works. There's two main ways to have persistent user account information stored. The first is through sessions, and the second is through these things called JSON Web Tokens. We're going to go through each of them in brief. Again, this is very conceptual, very theoretical. Okay, so first with the with the sessions. There is an image of a cookie. I'll explain what that means right now. The way it works is your client sends a login request to the server or the backend with your username, password, let's say, your authentication. The server will authorize you. It'll verify that your authentication is valid, and it will store something called a session for that specific user. That session will have an ID, which it sends back to the client in the response. And the client will be able to save that session ID in something called a cookie. So if you've ever gone to a website and they've asked you to accept cookie stuff, there's a pop-up or whatever, that's what's going on. They're storing data in these things called cookies, which are just, you can think of them as persistent states of websites. So if you're logged into Google, maybe Google has your session ID stored on your browser in the cookies. They just persist there. Okay. So now that you have your session ID written in your cookies on your computer, every single time you want to make a future request, which might require your personal user identification, you just send that request and you attach the cookie, which has your session ID stored in it. So now every single time you send a request, it contains that session ID information, which the server can then verify. It can look up that session ID and be like, oh, this is Daniel logging in again. This is Daniel making another request, right? So then it can send you the appropriate response with your personalized user information. Okay, so the key thing to remember, sessions are stored on servers. Your browsing session, all of that information is stored on the server. All that the front end knows about is the session ID. On the other side, there's the JSON Web Tokens. So the way this works is, again, it starts the same way. You submit a login request from your client to the backend. And it creates this thing called a JSON Web Token, which is basically just an encrypted, it's an encrypted block of information which stores your user information. And it's basically a session that they compress into this encrypted block and they send it back to you. So that instead of just sending back the ID, they send back all of that information and encrypt it, and you store it on the front end. So then every single time you want to make a request, you attach your JSON Web Token, which the session verifies each time. So this here is the first sort of thing we have to think about with security and these accounts. There's always wrongdoers out there, and they're going to try to steal your personal information, right? So you just have to be careful with these things that your session ID or your JSON Web Token don't fall into the wrong hands. Otherwise, they could pretend to be who you are and get all of your personal information. Okay, so just to recap, tokens are stored on the client, sessions are stored on the backend. There are two main ideas for having persistent user sessions. Okay, so let's talk about some nitty-gritty details behind authentication. Specifically, let's say we wanted to use a user password combination to log into a website. Okay, so maybe what we could do after learning about databases last week, we could have the user schema store the user's name as well as their password, right? So let's say my password is weblab is cool. Then my user schema would be name Daniel, email danson@mit.edu, password weblab is cool, etc. It turns out that this is a very bad practice for a variety of reasons, to store just the plain text password in the database. Can anyone think of a reason why this might be bad to just store it as the vanilla plain string text? Yeah. Yeah, exactly, right? So if someone doesn't have to hack into your website, they don't have to hack into your server. All they have to do is to hack into your database, and they'll get all the users' passwords just like that. And actually, it's quite easy sometimes if the developers are a bit careless to get this information. For example, you could accidentally push your Atlas SRV that we used last week to your GitHub. And if your GitHub's public, anyone can just read that string and be able to access your MongoDB, right? So that's one reason why it might be bad. Another reason is you don't want the developers to be able to easily look up the user password information, because a lot of users, myself included, will use the same password across many different sites. So if my password on your site is weblab is cool, and my password for my Gmail is also weblab is cool, that would be pretty bad, right? You could just take that password, and potentially do some bad things with it. So instead, what we'll do is we will use this thing called password hash salting. So let's say my password is Apple. Instead of storing Apple in the backend, what they're going to do is they're first going to add this salt, which is a random string. And then they're going to use this thing called a hashing algorithm. The mathematics is a little bit beyond the scope of this class, so we're not going to talk about it. But basically, it takes an input, a string, and it outputs this really long string that it'll always output the same very long string, but it's very, very difficult, near impossible for you to do the inverse of the function. So it's very hard for you to go from that really long random string back to the password. And what it'll do is it'll store this information in the database. It'll store the hashed, salted version of the password instead of just the vanilla password. So now every single time you log in, you say, okay, I'm Daniel, my password's Apple. It's going to add the salt. It's going to run the hashing algorithm, and then it's going to check whether that result matches the hashed password that's stored in the database. So this is a better way of doing username password authentication. Okay, cool. So all of that was highly theoretical, maybe a little bit complicated. And the good thing is we don't need to know about that for this class. Storing passwords is pretty hard. It's annoying to figure out. So what we've done instead with the web lab skeleton is we've implemented a different way of logging in. We've decided to let Google do this for us. And to sort of demonstrate how that works, we're going to run a little skit real quick. So Akshay and Alan, could you come up here? Okay, so let's say Akshay has a website, and I'm trying to log into Akshaj's website, right? So I might go up to Akshay and say, hey, Akshay, hey, you remember me, right? My name's Daniel. Can I get into your site?
What's your username?
My username's Daniel.
What's your password?
Shoot, I might have forgot. All right, can we try 1, 2, 3, 4, 5?
Nope, incorrect.
Okay, 1, 2, 3, 4, 5 is not correct. What about QWERTY?
Nope, incorrect.
Okay, QWERTY's not good. WebLab is cool?
Nope.
Okay, man, I don't know how to get into the site. What can I do? How can I get into the site? Well, I don't remember my password, but what I could do maybe is use Google, right? So I could come up to Google. Hey, Google, you know me, right? I'm Daniel. We know each other. Hey, how's it going? So I'm trying to get into Akshaj's site. Could I get a pass to do that?
Yeah, I got you. Here you go.
All right, thanks, man. All right. Hey, I'm trying to log in as Daniel, and I have a Google pass.
Give me a sec. Hey, Google, is this a good pass? Yeah, good. Okay, you can come in.
All right, thank you. And now I'm logged into Akshaj's site. All right, cool. So that's how we're going to do it. And now we're going to walk through what that might look like with some diagrams. So the way it works is your client is going to log into Google, right? So hopefully you still, even if you forgot your password to Akshaj's site, maybe you still remember your password to Google. So you authenticate yourself with Google. And Google says, okay, good job. Yep, I recognize you. Now let's say you tell the site that you're trying to log into, hey, I'm actually me. Google said so. What they can do, maybe, is they can then say, okay, I believe you. Let's take the user. Let's look at our users, find your user information, and let you log in. So something's missing here. Does anyone know? Can anyone tell me what was missing from the skit versus this diagram?
communication between server and Google.
Exactly, right? The communication between the server and Google. So this is the key part of why Google authentication works. You can't just tell the server that, hey, I logged in as this person. That's not going to work, right? Because then a hacker could just come up and say, hey, I logged in as this person. The server has to then take those credentials and verify them with Google. So that's the difference, right? You could feasibly pretend to log into Google with a fake password and then do the same thing. Tell the website you're trying to log into that you're this fake person. So that would be bad, right? So the way it actually works is you log into Google. Google gives you the token. That was the Gatorade protein bar in the skit. And instead of saying that you are a certain person, you just give them the ID card, the token. Google will verify that the website will verify that with Google and ask if the token, if the pass is legit. And if Google approves it, then only then will it find your user information and log you in. Okay, and this is the secure way of logging in that we use in this class. Hopefully you believe it's secure as well. The last time I tried hacking Google, it didn't go so well. So if you think you can hack Google, maybe you don't think this is secure, but good luck with that. Okay, so let's talk about the actual code for how this works, how this might look in practice. At the end of the last workshop on databases, this is what our app.js component looked like. It was very simple. All it did was it returned some HTML-like code that had other React components sort of nested in it, right? With authentication, we're going to be able to do a lot more things with our code. It's going to be a lot more nuanced. And what that means is that our code is also going to look a little bit more complicated, our app.js. But don't worry, let's sort of break this down and walk through each addition together. So you can see at the bottom, it's still returning that HTML-like code, and it looks pretty similar. There's a couple changes. So let's first focus at what's going on at the top. Okay, so the first new difference, what's the first new difference that someone sees here? Everything's different, so you can just pick one of them. Yeah.
Just two different things depending on whether you love.
Where are you seeing that? Okay. Yeah, we can talk about this use effect thing. I guess it first makes sense to talk about the use state at the top, because in use effect we're calling set user ID. So let's talk about that one first. So at the very top on line 17, we see const user ID, set user ID equals use state null. So what this is doing, if you guys remember from the React lecture on use state, all it does is it creates a state, right? And it sets user ID to the argument, which is null. And set user ID is a function that modifies user ID. So that makes sense. Initially, there's no user who's logged in, right? There's no user ID, so it makes sense for it to be initialized to null. In the use effect section, remember use effect is where we have all of our API calls, the things that take a long time to load. And what we can do here is we can make an API call to the backend to see who am I. So the backend will respond with the user information. And what we can do then is store the user ID in this state. So that's what that line of code is doing. So when we visit the website, we're going to check to see if there's a user logged in. And if there is a user logged in, then we're going to set the user ID to the ID of the user who's logged in. OK, this last part here, all it is a function declaration. We're declaring a function. We're defining it called handle login. What it does is it takes a res object, which is short for response, and it defines the user token. It sort of takes the user token out of this response. And then what it does is it posts to the login endpoint. So it tries to log in with that user token. So if you remember earlier, we were talking about the sessions and the JSON Web Token stuff. That's kind of what's going on here. We're taking that user token, that little thing that says, I'm this user, and we're saying, OK, let's use this to log in. It's going to return the user object, and then we'll set it to we'll set our user ID to the ID of that user. OK, in the bottom part of that code where it's doing the same return statement, you might notice that there's something a little bit different. So into navbar, it used to just be navbar, but now we're passing in some props. We're passing in handle login, which is a function, handle logout, which is another function, and the user ID, which is part of the state of app.js. And let's take a look at what navbar has changed, how navbar has changed. So at the top of navbar, now we're importing a couple things. We're importing Google Login and Google Logout. Those are the buttons for logging in and logging out, as well as this Google Client ID, which is just saying, OK, this is the app that we're going to use this Google stuff for. That's just a way of your app and Google to communicate which app that they're going to be authenticating. And if we look at the return statement of navbar, this is a really key example. It's a canonical example of how we're going to be using that user ID. Right? So if the user is logged in, then the props.userid exists, which means that we're going to render that first thing, which is the Google Logout button. Otherwise, we're going to render that second thing, which is the Google Login button. So if the user is logged in, we're going to have it display the Logout button. If the user is not logged in, we're going to have the website display the login button so that the user can log in. Right? If anyone has any questions about this code, feel free to ask right now. Ask in the questions doc. Add yourself to the queue. Whatever floats your boat. But that's basically how login works at a high level. I think it'll make a lot more sense when you just look through the code, look through the skeleton when you download it, and sort of walk through, see the specifics of what's going on. But these are just some of the things that we can do with the power of accounts and being able to log in. All right. I think Nick's up next. Sockets.